So the next thing we're going to do is review how to find the equation of a line if we're given 2 points on that line. We're going to need this later when we talk about demand functions. So let's review it first without any context. Suppose we want to find the equation of the line that goes to the points 2, -2, and 1, 4. Here are the steps that we're going to follow on the following slides. The first thing we're going to do is find the slope of the line by using the equation for slope. After that, we're going to use the slope that we find to compute the y-intercept of that line. Next, we're going to actually put the equation together, and then as the last step, we will test to make sure that the equation actually works using the given points. So let's go ahead and take a look at how this works with these 2 points. Our first step is to find the slope of the line. So the way I typically recommend that students do this, especially if they're reviewing this after not having done it for a long time, is to place those 2 points that are given to you vertically. So put them right on top of each other. That way we can see that the 2 coordinates, the 2 x coordinates line up and the 2 y coordinates line up. And the reason we do that is because the equation for the slope, which is the change in y divided by the change in x, is given by y2 minus y1 divided by x2 minus x1. So in the numerator, we have to be able to correctly identify the 2 y coordinates for the 2 points that are given to me. So you can see here the first point, 1, 4, has a y coordinate of 4. The second point, 2, -2, has a y coordinate of -2. So here in this computation you see up on top in the numerator, y2 minus y1 is 4 minus a -2. Now note, there are 2 negative signs here because the first one on the outside of the parentheses is for the minus that you see in the general equation, and the second one inside the parentheses is the sign of the actual y value for the second point. So on the top we have 4 minus a -2. On the bottom we have 1 minus 2, which is the change in the x. Now, by writing these vertically, we notice that this helps us to keep the order of subtraction consistent. So if I do 4 minus a -2 in the numerator, I must do 1 minus 2 in the denominator. So the order of the subtraction must be consistent on both the top and the bottom when you do this kind of calculation. Otherwise, you're going to get an error for the slope. Once you have this carefully written out, and I do suggest you write it out until you're used to these kinds of calculations again, then you're just doing arithmetic. 4 minus a -2 is +6, 1 minus 2 is -1, and so this corresponds to a slope of -6. We can also think of this as -6 over 1, which tells me that for every +1 that I move in the x direction, I have to move 6 units down, due to the negative sign, in the y direction. So now that we know the slope, which is -6, let's go ahead and do the next step, which is find the value of the y-intercept. You can see the steps laid out here on the right side, but let's walk through them one step at a time to make sure you know what's going on here. So first of all, we start with the general equation of the line, y is equal to m times x plus b. Now, in the second step, because we already know the slope is -6, all we're doing is substituting the value of -6 where we see the m. So we get y is equal to -6 times x plus b. Now for this to be a final equation of a line, we need to know the value of b. Notice that if we had a y and an x value, specific values of y and x, we could plug them in and then solve for the value of b. But we do have specific values of y and x. And in fact, we have 2 sets. The first point says that when x is equal to 2, y is equal to -2. And the second one says that when x is equal to 1, y is equal to 4. It does not matter which of these 2 that we use, we just want to be consistent. If I choose x equal 1, I must choose x equal 4. If I choose x equal 2, I must choose y equal -2. So I'm going to choose the point 1, comma 4, and notice on the next line, all I'm doing is I'm substituting y is equal to 4 and x is equal to 1, because those two numbers go together on a point. With that done, I can simply do the calculations, solve for b. Notice that what I do here is basically just add 6 to both sides of the equation to isolate the b. That gives me a value of b equals 10. And so now I know m and b, and so my final equation is y is equal to negative 6 times x plus 10. That's our equation of the line. Okay, so now we have the equation of the line. What we want to do now is test to make sure that it works correctly. You can see here the graph of the line looks just like we would expect it. We know the y-intercept is 10, so you'll notice that the line is intercepting the y-axis at 10. And the slope is negative, in this case negative 6. So the line is going down as we move from left to right. So our equation was negative 6x plus 10. And so we're going to test whether or not that equation actually works. Now because we used the point 1, comma 4 to create the equation, we're going to use the other point, 2, comma negative 2, to make sure the equation works correctly. And the way we do this is we substitute the value x equals 2 and y equals negative 2 into this equation to make sure that the result is actually a true statement. So when we do this, we will get on the left y is equal to negative 2, because that's the y-coordinate of the point we're testing, is equal to negative 6 times 2, because x here is 2 for this point, plus 10. When we do some simplification on the right, we get negative 12 plus 10, and then further simplifying gives me negative 2. Now, this is a true statement. Negative 2 is certainly equal to negative 2, and when we get a true statement in a situation like this for this test, it confirms that that point, 2, negative 2, actually does exist on that line. And so literally what we're demonstrating here is that this point here, 2, comma negative 2, is on the line and satisfies the equation y equals negative 6x plus 10.